All right, so this is continuing our new unit for trig. Okay, you guys had a review on special rights. We went over a few cases of special rights in the previous class. Now we are going to do a warm-up, okay, 1 through 6, okay, on the first page of the notes. We will check those answers shortly. I'll give you a few minutes. If you want to pause the video now and look back at last class notes on special rights, and complete 1 through 6. So pause the video now. Okay, here are the answers for review of special rights on the notes. This is what you see. Okay, we should have been able to find those values, okay, with the special rights. Then if you look below on the notes, we get into review of trig ratios. Now this is not special rights, it's just different angles, degree measurements given to us. You will need your calculator, but make sure it's in degrees. So right now you're given angle, given this angle is 65. So this 65 degrees across from 65, you're given opposite and then adjacent, which trig ratio based off of SOHCAHTOA represents opposite over adjacent. That is correct. Tangent. But in order to find this side length, we have to set up a ratio, which looks like, pardon the handwriting, tangent of 65 equals a over 20. We're trying to solve for a. So we then multiply 20 times tangent of 65, and this is the important part. If you do not have it in degrees, you're going to get a negative value, which we're not going to see here. So make sure it's in degrees. 20 times tangent of 65, you should end up getting 42.89, and we round to 42.9. Some of you might round to 43. But again, we like to keep it either to the hundredths place or to the tenths place. Here they're giving you a whole number, so I would take 43 as an answer as well. So why don't you try 8 and 9 using our trig ratios, either sine, cosine, or tangent, depending on what's given to you, and round to the tenths place. So pause the video and try those now. Okay, for 8 and 9, you should have got 13.9 centimeters and 105.3 yards. They both happen to be cosine ratios. The first one was similar to number 7. 8 was very similar to number 7 in terms of the setup. However, in 9, you are given the adjacent side and have to find the hypotenuse. So you have to do a little extra here, one extra step in order to find the hypotenuse. So hopefully everyone got that. So now I want you guys to try, and again, we've been doing this already, just a little recap, a refresh of SOHCAHTOA. So if you go through example 1, 2, and 3, okay, for example, example 1 is find sine of A. So I'm going to mark sine of A, or the angle A, mark angle A, and this is opposite, this is adjacent, and this is hypotenuse. So what's the sine? Well, it's opposite over hypotenuse. So we should get 3 over 5. So now go through example 2 and 3. Again, pay attention to what angle they're asking you to mark and find the cosine and tangent, and we'll see those values shortly. Okay, so example 2 and example 3, this is what you should have gotten. The cosine of B is 3/5. The tangent of B is 4/3. So again, it's just going through your SOHCAHTOA properties, as well as on the answer key for this, I also put another trick at the bottom. It's called circumference. As you label R for your hypotenuse, because that's going to be eventually the radius of our unit circle. Then you have X, which represents your x-axis, and y, which represents your y-axis. So s is your sine, so that's y over r, which makes sense because that's opposite over hypotenuse. Then cosine is x over r, adjacent over hypotenuse, and tangent is y over x, opposite over adjacent. So again, this is another tool that you will be able to use to remember, especially when it comes to the unit circle, which we're actually starting right now. Great, so now we're going to use our special right triangles and fill out the unit circle. Well, the unit circle is made up of a radius that is 1. Therefore, you see all three of these triangles with a radius, or hypotenuse in this case, of 1. So I'm just going to highlight, and that's not what I wanted. Wanted yellow. Uh, Highlight the hypotenuse, yellow. Oops, yellow and yellow. So that all represents 1. So knowing your trig ratios, this is a 30, 60, 90, 45, 45, 90, and another 30, 60, 90. So I want you to find out the missing side lengths of each triangle, and then we're going to use SOHCAHTOA to find sine, cosine, and tangent. Give you a few minutes. Right, so what you notice is the colorings that I put here for the 30, 60, 90. You notice hypotenuse again is all yellow. Across from 30 I did green, and across from 60 I did blue. For 45, both side lengths are pink. Now these colors represent some values that you should have found out. So for 30 degrees across from 30, we should have gotten 1/2. Across from 60, we should have gotten root 3 over 2. Now, again, the hypotenuse is 1. We know to find this side length, it's a, but to find the hypotenuse, it's equal to 2a. So 1 equal to 2a, divide by 2, that's how you get 1/2. Then we know the side length times root 3, so it's 1/2 times root 3, simplified as root 3 over 2. Then what do you notice from this first triangle to this triangle? It's another 30, 60, 90 with the same hypotenuse. What's going to happen to the two side lengths? Well, they're going to switch. So same measurements as what we see here. However, it's just a little bit steeper. So from 60 degrees, it's root 3 over 2. Across from 30 is 1/2. Okay. Now 45, 45, 90 should be the easiest one because both side lengths are going to be the same. So we know that hypotenuse is equal to a root 2. So you divide it by root 2, multiply top and bottom by root 2, and you will end up with root 2 over 2 for both side lengths. So right now, if you notice below the three triangles, there are your trig ratios, cosine, sine, and tangent of each specific angle. So what I want you to do is take a minute or two to establish cosine, which is given to you first, and there's a reason for that. We'll get to that in 1 second. Then sine, then tangent. So take a few minutes. Okay, so for the following measurements, cosine of angle A is root 3 over 2. And if you want to remember x over r, that works as well. Sine of angle A is 1/2, which is the green side length across from 30. Then tangent is y over x. Now, since they have the same denominator, those eventually will cancel out. So you're just looking at the numerators. 1 over root 3, multiply top and bottom by root 3, and that equals root 3 over 3 for the tangent of angle A. Then we move on to the second triangle, which is 45, 45, 90. Again, cosine and sine are going to be exactly the same. Tangent, root 2 over 2, root 2 over 2. So root 2 over 2 over root 2 over 2 will give you 1. So the tangent of angle D is 1. Then if you look at the third triangle, very similar to the first one. However, our values are switched. So the cosine of angle G is now 1/2 because it is the adjacent side. Sine of angle G is √3/2, and now the tangent is √3 because it's y over x. Okay, so now that we figured out special rights with a hypotenuse of 1, you notice the measurements of these angles, okay, and 30, 60, 90s, you notice cosine and sine are switched, and the tangent is √3. So if we look below here, suppose that point P is the point on the unit circle, meaning the radius is 1, obtained by rotating the initial ray. The initial ray is going from here to the point P. What is the length of OQ? The horizontal leg is √3/2. Horizontal is representing the x value. What is the length of QP? The vertical leg is 1/2. So again, horizontal is going to represent your x value, and the vertical leg represents your y. So now you're trying to find the sine and cosine. So the sine of 30 degrees opposite over hypotenuse is 1/2. The cosine of 30 degrees adjacent over hypotenuse is √3/2 over 1. So the cosine of 30 is √3/2. So again, sine represents what values? Your y values. Cosine is represented by your x values. Okay, so sine of 30 degrees is 1/2. Cosine of 30 degrees is √3/2. Then we do the same thing for 45 and 60. All right, so now we're going to look at 45 degrees. Remember, the hypotenuse on all of these is 1. So if you look above for 45 degrees, you have √2/2. The same thing here, √2/2. So if we're trying to find the sine of 45 degrees, opposite over hypotenuse. So the sine of 45 degrees equals √2/2. Then the same thing for cosine of 45 will equal the same thing, √2/2. So if you notice, 45 degrees have the same measurements. So those are going to be the easiest to remember, okay? With 60 degrees, remember it's going to be switching the two lengths that we found. So before, for 30-degree angle at the top, this was √3/2, the horizontal leg. But now the vertical leg is √3/2. And the horizontal leg is 1/2. So if we had to classify this, meaning the sine 60 is again opposite over hypotenuse. So that means it's √3/2. And then the cosine, and you abbreviate it like this as we saw above, 60 is 1/2. Okay, so that completes actually the first quadrant of our unit circle. Now the quadrants, remember, quadrant 1, 2, 3, 4. So we pretty much completed this first quadrant that's part of our unit circle. Okay, another part that is on the unit circle is radians. Now, one complete revolution, meaning one complete rotation around this circle, is 360 degrees. Now, with radians, it's 2 pi radians. So one full rotation is 2 pi radians. Now, a radian is a unit of angle measure at the center of the circle whose arc length is equal in the length to the radius. So this arc length is the same distance as the radius, okay, or here, the radius, either one. Um, Again, the radius for the unit circle is equal to 1. But what we're going to see now is we're going to convert each degree measured to a radian measure. So here's some formulas to remember. You are not given these, so you should remember them. Given degree times pi over 180. You're not actually multiplying by pi, you're kind of tacking it on at the end. So you will need your calculator for this. Eventually some of these you will be able to reduce. So here you have 150 degrees and you want to multiply by pi over 180. Oops. So what you're going to notice is it's 150 over 180. And then what we do is we just tack on pi. But we want to reduce this. So one way you could reduce it by your knowledge of reducing fractions, or we could use our calculator and do 150 divided by 180, hit enter, and obviously you get a decimal. But we need that in fraction form. So you do math, frac, enter, enter, and you should get 5/6, which is exactly what we want to see. So in radians, 150 degrees is 5/6 pi, or 5 pi over 6. That's your radian measure for 150 degrees. So I want you to do the same thing, 2, 3, and 4. I will pause the video, and when we get back, you'll see the answers. Okay, so the following degrees converted to the following radians. So 210 degrees is equal to 7 pi over 6. For 45 degrees, it was pi over 4. And 240 degrees, it was 4 pi over 3. Okay, so hopefully everyone got those conversions correct. And again, these specific scenarios, you will not need a calculator. You could just reduce the fractions completely. However, once we move past and have some degrees that fall on the unit circle, but we don't really classify them too much, and you'll see what I mean once we get to the unit circle, we would need a calculator to convert it. So now in the reverse direction, we are going to look at from radians to degrees. So this is going to be the opposite now. So we have pi over 6. We are going to multiply by 180 over pi. So what you're going to notice is this will equal 180 over pi, or 180 pi, excuse me, over 6 pi. Well, right now you should be able to see that you could cancel out those pi's. So all you're doing here is dividing 180 by 6, and you end up getting 30 degrees. Okay, so again, here you will not need a calculator too much. However, if you need one, just you're tacking on pi and those end up canceling out. So what I want you to try is 6, 7, and 8, and we'll check those answers in a few minutes. Okay, so converting each radian measure to degree, you should have gotten these below. For pi over 4, that's 45 degrees, and we have it above as well for number 3. Then for 7, we have 5 pi over 6, which is equal to 150. And then 7 pi over 6 is equal to 210. So we should have gotten all those from radians to degrees, okay, and degrees to radians. So I want you to try the practice below, okay, and look at the answer key, which I'll show in a minute, to compare your answers. Okay, make sure everybody's on the same page, and then we will move to talking about how does this apply to the unit circle. Okay. Okay, so for the practice below, going from degrees to radians, should have got the following. And then from radians to degrees, should have got the following as well. Again, it's just the conversion formula. You're not really multiplying by pi. You're kind of just tacking it on and reducing your fractions up here. And then for radians to degrees, you are canceling out your pi values. Okay, so again, that's from radians to degrees and degrees to radians, which we're going to need when filling out the unit circle. All right, so we're going to take what we learned from degrees and radians and also where we started with special rights. So first and foremost, this is the unit circle. We use this to find measurements of angles as well as when we get into trig graphs as well. So one thing to know that your radius that goes around all the way is a radius of 1. Okay, just like what we saw the 3 triangles we did earlier. Okay, so first and foremost, we always start on this right hand side. So what I'm going to do is I am going to label or highlight, I should say, where we start, typically the unit circle. So picture this as if I go all the way across, that's the x-axis, and then up and down, vertical, is your y-axis, creating a 90-degree angle. Well, if you look back at what was created earlier using our 3 triangles, all with a radius of 1, okay, so that means this hypotenuse is 1, this hypotenuse is 1, and this hypotenuse is 1. So if that means our hypotenuse is 1, what is the length from the center of the circle to the edge of the circle? Okay, and what value is that going to be? X or Y? Okay. This value here is going to be your X value. Okay, X value. And your Y value, since there's no height, is 0. And your X value is 1. Well, if we travel up here to 90 degrees, because it's creating a 90-degree angle, and this was 0, what would my coordinate point be? Well, if this is 1, 0, and my 90-degree, I have the height, but it's against the y-axis, so basically I'm creating a y-intercept. That would be 0, 1. So far, we filled out something called a quadrantal angle, meaning 0 and 90. Well, what are the other triangles that we filled out earlier? Well, we have 30, then we had 45, it's not going to let me do a 45, that's a 4, and then we have a 60. Okay, and I have a better diagram coming up shortly. So we figured out these triangles, and if you were to drop a perpendicular line from the point on the circle straight down, you create another right triangle. So again, hypotenuse is 1, 30-degree angle. This black line, this perpendicular line, would be your y value, and this would be your x value. So if you look on this page, okay, I highlighted the quadrantal angles as pink, okay, 30-degree angle as yellow, 45 as green, and 60 as blue. So the reason for this is when we fill out the whole triangle, you're going to notice some similarities. So again, we just went through these guys here, quadrantal, 0 and 90. Then if you look back and see what your 30-degree angle was, here's 30. We know that the long side here was 1/2, and our horizontal leg was √3/2. So horizontal comes first, √3/2, and 1/2 would be your coordinate for 30 degrees. So for example, if I wanted to know the cosine of 30, and we saw this earlier as well, it's √3/2. Cosine is your x, sine is your y. Then we get into 45 degrees. Well, those are the easiest because the coordinate is the same for x and y. Then we look at 60 degrees, which is steeper. However, it's very similar to 30 because it's a 30, 60, 90 triangle. From horizontal leg is now 1/2, and your vertical leg is √3/2. So those just switch places. So what we just filled out is the first quadrant of the unit circle. So I want you to ask yourself, do you see similarities all the way around? Can you make some connections? So pause right there, and then we'll fill out the rest of the circle. Okay, so you notice first quadrant, all my coordinates are positive. What's going to happen when I move to the left-hand side? If once I go past 90, does anything change to the coordinate points? If you said your x values become negative and your y still remains positive, you are correct. So we just filled out the first quadrant of the unit circle using the coordinate points that we figured out from the beginning of the lesson. Now we are heading into the second quadrant, which is what you see here. So again, from 90 to this first angle, it's 120. Okay, it's 30 degrees. Then in between, you're adding 15 and then 30. So that's how we get these degrees. Now I labeled them specific colors due to the fact the coordinates are going to be exactly the same. However, something is going to change. What changes once you cross over into the second quadrant, your x or your y? Well, your x becomes negative. So we see here that this is a blue line. Well, it's very similar, not the same. It's referring to 60 degrees. So if I was to drop a perpendicular line from this point on the circle at 120 to the x-axis, I would create a 60-degree angle. The only thing that's going to be different is we will be tacking on to these x values a negative. So there's a negative 1/2 and positive √3/2. Again, same coordinates. However, your x value now becomes negative. So for 45 degrees, we did green. That's the same as 135. So this coordinate is going to be exactly the same. However, your x value will be negative. Okay, same thing applies for a 30-degree angle. Same coordinate, however, your x value is going to be negative. Okay, just the negative x because that's what's negative in the second quadrant. Then another quadrantal angle, just like 0 and 90, is 180. Well, that's halfway around the circle. Well, I should have the same coordinate as 0 degrees and 360, but what's going to be different? Oh, since it's the left-hand side in the second and third quadrant, my x value is going to be negative as well. Okay, so again, coordinates are still the same. If you know this first quadrant, you could fill out this whole entire unit circle. So what I have below is the third and fourth quadrant, where again, same coordinates, but what's going to change? Their signs. So 210 is very similar to 30 degrees. However, in this case, what happens to x and y in the third quadrant? They're both negative. So tack on negatives here. Negatives for 225, same angle as 45 degrees. And tack on negatives for 240. Again, similar to 60 degrees. So just follow the lines because that will help you. Then we get to 270. Opposite from 90. So 0 is still the same for our x value. However, our y is now negative. Then as we move to the fourth quadrant, what's positive, what's negative? Again, same corresponding lines, blue for 60, green for 45, and yellow for 30 degrees. Well, in the fourth quadrant, y is still negative. However, x is now positive. And 0 and 360 will be the same coordinate point, 1, 0. So right now, we just completely filled out the unit circle with degrees and coordinates. Degrees and coordinates. So now we're going to add these little blanks. Those little blanks are for radians. Before we get to radians, there are some patterns you could start to figure out. Okay, start to figure out is if you look at the x values, they go 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. You could do it that way. Some other people use using 5 fingers. They could figure out the coordinates based on the first quadrant. But again, if you know the first quadrant, you could fill out the rest. That's all you need to know. Okay, first quadrant, if you memorize the first quadrant, you'll be able to fill out the whole entire unit circle. There's also a trick with radians as well. All right, we're going to start off with quadrantal angles because it's easier to figure out. Okay, and there's a few others that you'll be able to figure out as well. So we know that one full rotation is 2 pi radians. So that's 360 degrees. It's 2 pi. Now, what is half of 2 pi? What is half of 360? 180. Well, half of 2 pi is just pi. Then if you look at half the circle from 0 to pi, what is 90 degrees then? 90 is half of 180, so this must mean pi over 2. Then if you go to 270, okay, you have 1 pi, then you have another half of pi. So this would be 3 pi over 2, finalizing with 2 pi. So if I look at this 90-degree angle here, I have 0 to pi over 2. Well, or 0 to 90. What's half of 90? 45 degrees. What's half of pi over 2? Okay, so now that we established 45 degrees is pi over 4, what you can do, one trick, is instead of using the conversion formula, every 45 degrees, you're adding 1/4. So for example, we start with pi over 4. If I add a fourth, that's 2 pi over 4, which reduces to pi over 2. If I add another 1/4, so this is 1/4, 2/4, this would be 3/4. Add another 1/4, I have 4 pi over 4, which is just pi. If I add another 1/4, I have 5 pi over 5, 4, 5 pi over 4. If I add another 1/4, I have 6 pi over 4, which reduces to 3 pi over 2. If I add another 1/4, I have 7 pi over 4. If I add another 1/4, it's 8 pi over 4, which reduces to 2 pi. So if you notice all the green angles have a denominator of 4, meaning the reference angle, which we'll get to next time, is 45 degrees. So that's one hint to remember what your radians would be for 45-degree angles. And once you go past it, 135, 225, and 315. Our next is going to be 30 degrees. Okay, so looking at 30 degrees, every 30 degrees, you're adding 1/6. So we have pi over 6, then we have 2 pi over 6, which reduces to pi over 3. Then we have 3 pi over 6, which reduces to pi over 2. Then 4 pi over 6 reduces to 2 pi over 3. 5 over 6, 5 pi over 6. Then 6 pi over 6 reduces to pi. 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6. And then we have 12 pi over 6, which reduces to 2 pi. Now, if you look at this diagram, you're going to notice that all 60-degree angles, or reference angles, meaning their coordinates are exactly the same, just different signs, in radians, their denominator is the same. So 60, 120, 240, and 300 all have these blue lines as well as a denominator of 3. 45, we talked about before, the green lines, also same coordinate points, root 2 over 2, root 2 over 2, except if they're negative or positive, all have a denominator of 4. Then 30 degrees, which is the yellow lines all the way through the unit circle, same coordinates, root 3 over 2 and 1/2. The radians have a denominator of 6. So that's another way to remember. Here is the completed unit circle, okay, as well as I also have it on this note sheet as well. So once you check your answers, again, I did coloring so you could see um, the unit circle, and I just noticed a issue. You guys probably will as well. This at 3:30 should be 11 pi over 6, and I will change that before I post it. So we have completed the unit circle. Obviously, we're going to do more practice on this um, because it's a lot to remember. So check Google Classroom to see what your practice will be for this assignment.